Hey,
Okay.
do you have a minute? I need help with homework.
Yeah, absolutely.
So I'm doing my atomic structure worksheet, and a lot of it I get, like stuff like subatomic particles, but like stuff about like electron cloud theory I don't understand. Could you just help me out with that?
Yeah. Just want to go down the homework.
Yeah.
Okay.
Question one is asking me to draw a helium atom, and I've done that. I've added two protons, two of the positively charged subatomic particles, and two neutrons, which are neutral, of course, and then two electrons to make the charge of the helium atom neutral. And it asks if an atom has the molecular weight of 16 atomic mass units, how many protons, electrons, and neutrons does it have?
Right.
So if it has 16 atomic mass units, because electron mass is negligible, compared to like that of the protons and neutrons, that means that 16 mass units is the nucleus itself, which means because it's not an isotope, it's just a regular atom, it's going to be 8 protons and 8 neutrons, which means it has 8 electrons, right? And that would
Yeah.
be oxygen.
Obviously. Okay.
Yeah. And then it's asking what protons and neutrons are made of. I know they're made of quarks, but I don't really know what quarks are. Do you know what they are?
So quarks are the subatomic particles that are like a step smaller than our protons and neutrons.
Okay.
So there are a certain number of quarks that go into a proton. Is there another question about that?
Yeah, they're just asking what types there are.
What types there are? So there are 6 different types of quarks. You've
Okay.
got up, down, strange, charm, and then top and bottom.
Hmm.
They all come with their innate charges. There are positive ones that have values of 2/3 of a positive charge, and there are negative ones that have negative third charges. So, for example, the only ones that we really care about, the ones that like function within the like protons and neutrons that we talk about,
Right.
are the up and down quarks. So, a proton, for example, would have 2 up quarks and 1 down quark. So that's just 4/3 minus a third, and then you get
You get one,
one.
positive
Yeah,
one.
you get your positive one.
So like a neutron would have 2 down quarks and 1 up quark because it nets to 0, right?
Exactly.
Okay.
Yeah.
And then it's asking me to get into Bohr's atomic model and the electron cloud model. And I don't know really what that is.
Okay, so the Bohr's atomic model is just what we've been looking at since Gen Chem. It's
Okay.
got our nucleus in the center, and then it's got our electrons going around it in like these very stratified rings, right?
Okay.
So think of it like planets orbiting a star, and then to move between like different energy levels, it needs to absorb or release energy.
Okay.
But electrons can't exist anywhere in between those energy levels. That's Bohr's model.
Oh, that's the one where to go down an energy level, it has to emit a certain amount of energy in the form of light.
Right.
Okay.
Yeah.
Well
The thing
then,
with Bohr's theory is that it doesn't really work well with atoms that are more than one electron.
okay.
And that's pretty much all the systems that we care about.
Okay. Yeah.
At like this small at the quantum level, like things the size of electrons acquire wave-like characteristics. And with these wave-like characteristics, you can't say with certainty, like at any one point in time, where that electron is. But we can predict it with certain calculations.
Yeah, that's the
Sure.
last question. How do I do that?
How can the position of an electron be determined?
Or yeah, predicted, however.
Okay. Well, let me just share this with you real quick.
Okay.
Check your drive. I just share something with you.
All right.
So
Oh.
the way that we would predict the location of an electron is using something called the Schrodinger's equation.
All right.
So it's a differential equation that can predict where electrons are likely to be. So rather than on the clear path in the Bohr model, electrons can be found in certain atomic orbit spaces around the nucleus at different densities. And this is where the electron cloud model comes from.
Okay. Cool. And so all of these different variables, okay, I see all of their significances. So it relies on energy and potential energy of the particle. as well as the position of the electron. Okay.
And just remember that H is Planck's constant.
Right, okay. Cool. That was helpful. Thanks.
That it? All right,
Yeah,
sweet.
I think that's it.
I'll see you tomorrow.
See you. Bye.